Hi, Math 30-2s. Welcome to probability lesson number 6, probability involving permutations and combinations. So this is the last section of notes for this particular chapter, and this is actually your last lesson that you have to listen to me for Math 30-2. Okay, so once you finish this lesson, you're completely done the course, and then you can start preparing for the probability test, which I've listed the date on the Google Classroom. So what we talk about today, like I read in the title, is that we are going to be still discussing probability, obviously, but we can sometimes calculate it using permutations and combinations. So just remember, probability is always part to whole. Or in this case, what you're going to see is we're going to use combinations and permutations to figure out the number of ways something can happen. And then we're going to divide that by all possibilities. That will determine the probability of our event happening. When we were talking about permutations and combinations earlier, we were not discussing probability. We were just talking about the number of ways something can happen. If I want the probability, I then, like I just mentioned, must divide by all possibilities, okay? And that gives me the probability, and that's really the gist of what we're going to do today. So at the top of the page here, they give me a nice little review of what factorial notation looks like, permutations, the calculations with and without repetitions, and then combinations and the alternate form of notation for combinations, okay? That's just at the top of the page. So let's get into some questions so that we can go through them and I can discuss how we are solving each of these problems. So in class example 1, it says 2 cards are selected without replacement from a deck of 52 cards. Determine the probability that both cards are kings using the multiplication law, which is what we normally kind of think about when we use probability, and then combination. So you'll see I get the same answer both ways. When I look at the question, again, you may have noticed that when I read it, okay, I said without and kind of emphasize that. That's obviously important. So I'm not putting the card back, and then they want probability, and not just the number of ways something can happen, but the probability that something will happen. So when I first use the multiplication law, we're talking about both cards are kings. So we know there are 4 cards in a deck out of a total of 52. Okay, so there is me selecting the first king. Now there's no replacement here. So then I go down to 3 out of 51. Okay, so there is the probability that we are going to have for that first calculation using the multiplication law. Okay, multiply and then reduce, and we end up at 1 over 221. Okay. Now, when I use combinations, here's what's going to happen, right? When we were talking about, again, if you remember when we started talking about cards and combinations, it doesn't matter the order in which the cards are dealt to me in my hand, it just matters whether or not I have them. So if it's a combination, there are 4 kings, and I want to choose 2 of them, okay? Now, that is just the number of ways something can happen. To get the probability, I must divide by all possibilities, which in this case would be 52 cards in the deck, and I'm choosing 2. So 4 choose 2 is the number of ways that I can select kings, and 52 choose 2 is the number of ways out of a total deck I can get 2 card hands. When you do that calculation, okay, so we're going to go, remember, using math and probability in our calculator. 4 choose 2, divide by 52, choose 2, okay, fraction reduces to 1 over 221. So the same answer we got in A. Class example 2 here. In a card game, you are dealt 5 cards from a pack of 52 shuffled cards. When you look at your 5 cards, what is the probability expressed in combination notation, okay, that you have? And then they give me 4 scenarios here. So the things that are important here is we're talking about 5 card hands. We are talking about probability, and they want me to express it in combination notation, which was what I did in part B of class example 1 there. So I want to talk about 4 aces, okay? So I know in a deck I have 4 aces. I want to choose all 4 of those aces. Now, what remains is I still have 1 more card to choose, don't I? So I have to choose 1 more card. Now, that 1 remaining card is going to come from the 48 cards that are not aces, okay? So there's the combinations, okay, for me selecting those 4 aces. If I want probability, I must now divide by all possibilities, which looks like this: 52 cards in the deck, choose 5. And there you go. I don't have to work out the probability. The question just says state it in combination notation. So there is what that calculation would look like. Now in B, it says 4 tens and an ace. So the 4 tens part looks exactly the same as the 4 aces in part A. Now, the 1 ace is a little different, isn't it? Because in a deck, there are only 4 aces, but you want to choose one of them. So you now have selected your 5 cards. And again, you divide by all possibilities, which is 52 cards in the deck, and you're choosing 5. Okay, so there is what the combination notation looks like for B. In C, okay, you can see, okay, funny math joke there, that we have 5 different cards. Now, each of those cards you should recognize as there's 4 of each of those, okay, in the deck. There are 4 tens, 4 jacks, 4 queens, 4 kings, 4 aces. So the calculation for me selecting each of those cards that I've listed in C is exactly the same. For each of those cards, it's 4, choose 1, right? 4 tens, choose 1. 4 jacks, choose 1. 4 queens, choose 1. 4 kings, choose 1. 4 aces, choose 1. So I do that calculation of 4, choose 1 5 times. Okay, so I would be multiplying them all together, wouldn't I? So that's like 4, choose 1 to the exponent of 5. Then I divide by all possibilities, which would be 52, choose 5. Okay, and then in D, at least, okay, so we've seen that phrase before, 1 jack. So what does that mean? That means you could have 1 jack or 2 jacks or 3 jacks or 4 jacks, okay? So the only thing that's not there would be no jacks. So what I would do is I would take 100%, or the number 1, minus the probability of no jacks, okay? So in this case, I used, again, kind of the complement idea here to determine the probability. So it would be 1 minus... So what would it look like? Well, no jacks would look like this. 48 cards, choose 5, okay? Because I've taken out the four jacks. So 48 cards that are not jacks, choose 5. All over 52 cards in the deck, choose 5. There's what your probability would look like in combination notation. 1 minus 48, choose 5 over 52, choose 5. Okay, class example 3. The word counted has been spelled using Scrabble tiles. 2 tiles are randomly chosen, one at a time, and placed in the order in which they were chosen. Okay, placed in the order in which they were chosen. Determine the probability that the tiles are C and O. So again, what we want to make note of here is what I underlined, okay, and that's that order matters in this question. So with that, we are now focusing on permutations, aren't we? So when I have a C and then an O, there's only one way that that's going to happen, isn't there? One way. Out of 7 tiles, because there are 1, 2, 3, 4, 5, 6, 7 tiles, and I'm selecting 2 of them, but order matters, so it's 7p2. So it's 1 over 7p2, which is 1 over 42. Okay, now if you don't like that calculation, okay, and it doesn't make sense to you, you could think about it like this, or, okay, you could say, well, I know I have 2 spaces to fill. I have 7 possibilities, then 7 or 6 possibilities. That's 42, isn't it? 7 times 6 is 42. Okay, that gives you this calculation here, and there's only one possibility of it being the C and then the O. So one possibility out of 42 possible ways that you can put letters in those first 2 spots. All right, in B now, both are vowels. So I want the probability that I select both vowels, okay? So again, hopefully we know what vowels are, A, E, I, O, U. So you take a look at counted, and you will see that there are 3 vowels in that word. I have to select 2 of them where order matters. So 3 vowels, pick 2 of them. And that's out of a total of 7 letters, pick 2. So there's your probability. Okay, so 3, okay, P2, 6, okay, all over 7, P2, that's 42. That will reduce to 1 over 7. Okay, and there you go. Next page, okay. Mike's MP3 player contains 50 songs. If he listens to 10 songs on random, determine the probability. So again, we want probability, this time as a percentage to the nearest hundredth. Okay, that is 2 decimal places, that the playlist contains Mike's 2 favorite songs. So we're not talking about the order of these songs. They just have to be on the playlist or not on the playlist. So that's a combination, isn't it? So there are 2 of his songs that are favorite, and I choose both of them. So 2, choose 2. Now the remaining 8 songs, I have to choose 8 more, don't I? That comes from the 48 other songs on the playlist, right? Now that is just the number of ways that can happen. And I want probability, so I must divide by all possibilities, which is 50 songs, and I'm choosing 10. So I have to do that calculation, okay? So I am going to go to choose 2, okay, 48, choose 8, okay, and then I have to obviously divide by 50, choose 2. Okay, so when I get that as a decimal value, okay, you are going to see that I have 0, decimal 03, 673, etc. Okay, when I round to the nearest hundredth, that's 2 decimal places. That is going to be equivalent to 3.67%. Okay, and there is our answer. Now in B it says one of his favorite songs has to be at the beginning of the 10 songs and the other has to be at the end. Okay, so in this case, we're talking about order mattering, aren't we? We have one that has to go at the beginning and we have one that has to go at the end. So this time it would be the 2 songs that are his favorites, P2, the order matters. So 2 P2 and then 48 P8. Okay, we're talking about permutations this time, order matters. And now I divide by 50 P10, okay? Permutations this time versus combinations in C. So I go back, use the same numbers, but I am using permutations, not combinations. Okay, I just have to do the division here. Okay, and this will give me 0 decimal 0.00816, okay, etc. And as a percentage, this will be 0.08%. All right. Class example 5. City council consists of 9 men and 6 women. 3 representatives are chosen at random to form an environmental subcommittee. What is the probability that Mayor Jim Milanovich and 2 women are chosen? So again, here order does not matter. Okay, there is no head of the committee, president, vice president, secretary, treasurer. Okay, just again on the committee, not on the committee. So we saw this with combinations before. There's one Mayor Jim, and I'm choosing him, so he's on the committee. Okay, then what am I going to do? Well, I'm going to have 6 women, and I have to choose 2 of them. Okay, so there we go. There is the number of ways that that can happen. Okay, and then I divide, if I want probability, by all the potential possibilities, which are, so 9 men and 6 women, that's 15 people, and you have to choose 3. Okay, and there you go. So I do that calculation, okay, and okay, we end up with, okay, so 3 over 91. Okay. Now, what is the probability that 2 women are chosen if Mayor Jim Milanovich must be on the committee? Okay, so this time he has to be on the committee. So that's all that's happening. So when I do my calculation here, okay, it's going to look like this. I have the 6 choose 2, okay, so he's on there again. But what happens is in the bottom with the probability now, okay, it's just the 14 choose 2. Why is it 14 choose 2? Well, because Mayor Jim is taken out of the probability because he is on the committee. So there's only 14 people left and you just have to choose 2 more, okay, because he is on the committee. Okay, you're making sure he's on the committee. So that's the difference between A and B. Okay, so in this case now it's just the 6 choose 2 over the 14 choose 2. So this is 15 over 91. Okay, so in A, again, I know sometimes people are confused with this. In A, it's what's the probability that Mayor Jim and the 2 women are chosen. Okay, in B, it's what's the probability that 2 women are chosen if Mayor Jim must be on the committee. So in B, he has to be on the committee. In A, we're just determining what's the probability he could be on the committee. All right, class example 6 here. A hacker is attempting to break into a friend's security protected file. The friend tells the hacker all the numbers that are in the 4-digit PIN, but not the order or how many times each digit may be repeated in the PIN. Determine the probability that the hacker correctly guesses the 4-digit PIN on the first attempt if the friend tells her that the PIN contains, okay, and then they give us 4 scenarios here. Now, I have 4, 5, 6, and 7. Now, it's a 4-digit PIN, right? So I know that if I have 4 numbers, right? I have 4 numbers here. 1, 2, 3, 4. How many ways can you arrange four numbers. Well, that's 4 factorial. So that is 4 times 3 times 2 times 1. So that's 24 ways, okay, or arrangements for those four numbers. Now, the probability would be what? Well, if you're talking about a PIN for your bank account or a website, whatever it is, in this case, it's a security protected file, there is only one combination that works. So the probability would be 1 out of 24, okay, because only one code works, right? So it's what will work over all the potential codes that could work. Now in B, we're only using the numbers 4, 5, and 6. So, but remember, I have 4 spaces to fill here, right? So I'm using 3 numbers and I have 4 spaces to fill. So what's going to happen is one of these numbers, okay, is going to have to be repeated twice because you have to use 4, 5, 6, so that fills up 3 spaces out of the 4. The fourth blank, one of those numbers has to be repeated. So really the calculation would be 4 factorial, and you'd have to divide by 2 factorial, okay? Because you're going to be repeating one of the numbers. Now, I would actually have to do this how many times? Well, I'd have to do this 3 times, right? Because it could be the 4 that's repeating, the 5 that's repeating, or the 6 that's repeating. So I would do this calculation 3 times. So add them together 3 times or multiply them by 3. So this ends up being 3, okay, times 4 factorial over 2 factorial is 12. So this is 36 ways that I have when I'm using only 3 numbers. And again, with a security code or a PIN, there's only one way that works out of that potential 36. So it's 1 out of 36. Now I'm dealing with only the numbers 4 and 5, okay? So you have to think about what could happen here. If I only have the numbers 4 or 5, what would happen? Well, I could have a 4 and 3 5s, right? I could have a 5 and 3 4s, or I could have 2 4s and 2 5s, right? Those are the potential ways I could have the numbers set up in that code. So if I talk about this calculation, what would that look like? Well, I'd be arranging 4 things, so 4 factorial, and you divide by the 3 5s. This calculation would also be 4 factorial divided by 3 factorial, and the bottom one here would be 4 factorial divided by 2 factorial, 2 factorial, 2 repeating 4s, 2 repeating 5s, okay? So what this gives you is 4, okay? What this gives you is also 4, and this will give you 6. So out of these 3 possibilities, there are 14 ways or 14 arrangements if I'm only using 4 and 5. Again, we are talking about a security protected file, so only one PIN code or passcode will work out of these 14 potential different passcodes, okay? Now, the last one is interesting, okay? Interesting, not interesting, okay? Because you're only using the number 4, aren't you? So if you only have the number 4 and you have 4 spaces to fill, the only pattern here, okay, is 4, 4, 4, 4. So there is only one arrangement or one way, okay? So that's, you know, if you tell your friend you have a 4-digit code, but it only is made up of one number, well, I'm pretty sure that they are going to be able to guess it because there is only one arrangement. So in this question, the probability is 1 or 100%. Okay, and that's it. You guys are done Math 30-2, right? So again, practice these lessons. Send me any questions that you have, and please make sure you are staying up to date on the evaluations that I have listed on the Google Classroom when they are, and I will chat